first thing we're going to look at is probability distributions. What are they? So what a probability distribution does, it gives a numerical value to each outcome or event that happens. Basically, the probability of it happening. Outcomes can be, and you might remember this from junior stats, numeric. Okay? So it's possible for them to be numeric, where all the elements is a number, as the name suggests. The example I've got there, roll of a dice. You could get a 1, a 2, a 3, and so on. Or it might be categorical, where the actual events the outcomes are not numbers, but they're words or descriptions. So blood types, for instance, you could have O positive and B negative and things like that. Now we're going to be interested in what we call random variables, and a random variable is a function, but the value of that is this real number, which is worked out by the probability of the outcome happening. Notation wise, random variables we use uppercase letters. Value it represents we use the lowercase letter. Random variables can be continuous. Now they're continuous if the range of values forms an infinite set of real numbers. So it's like a continuous thing. There are no breaks. It's just a complete interval. They could also be discrete. So discretes are ones where it's just a series of numbers. So you don't necessarily have all the numbers in between. Now, it is actually possible to have an infinite number. So there's things that we call infinitely countable. You don't have to worry too much about that. But there is still possible to have an infinite number of things in a discrete one. And the example I've got there is, say we were doing some experiment and we wanted to know how many times we roll a dice before the number 6 comes up. I mean, theoretically, the number 6 might never come up. I mean, it's possible, incredibly unlikely, but it is possible. So you could have an infinite number of outcomes there. Okay, let's use the coin as an example. We're going to toss a coin 3 times. We're going to use capital X for our random variable. We're going to define it as the number of heads that ends up happening. The sample space, all the possible outcomes. Head, 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 tail, and so on. They're all the possible outcomes. So the sample space of X, the random variables, the number of times associated with each one of those would be 3, 2, 2, 2, 1, 1, 1, and 0. We can put that in a table, and this is what we call a probability distribution table. And it's simply the possible outcomes, 0, 1, 2, or 3, and then the second line is the probability of it happening. And you can see how I've written it. The probability of capital X, so our random variable, equaling little x, the probability of it happening. So probability of a 0 coming up 1 in 8, 3 in 8 for 1 and 2 and so on. We could draw a graph. That's what we would call a graph of the probability distribution. Very fancy name, I know. So some properties of this probability function. We always have got to get a positive number, because if we're talking about probabilities, you don't have negative probabilities. So you're always going to get a positive number. Further than that, we know all the possible probabilities must add up to give 1. So the sum of them all will always equal 1. Now if you look at our table there, sure enough, we will add those together. 1/8 plus 3/8 plus 3/8 plus 1/8. That's 1. Now, if the probability is the same for every possible outcome, then that's what we call a uniform distribution. And that will just do us for the start of this topic.